Welcome to STEM School. Unit 2, Introduction to Quadratic Equation. A quadratic equation is an example of a polynomial equation. We write y equals to ax squared plus bx plus c x to the power 0, x to the power 1. X to the power 1 equals x, and x to the power 0 equals 1. So that meant that it's ax squared plus bx plus c. Now this quadratic equation has two roots because the degree of polynomial is 2. Degree of polynomial is equal to 2, and that is the highest exponent. And the highest exponent is 2. 1 and 0, the highest exponent is 2. The a here is the coefficient of x squared. B is the coefficient of x. C is the coefficient of x to the power 0. Or sometimes you call C the constant. Example, a quadratic equation may look like this. So this is some examples where you have x squared plus 3x plus 2. In this case, you can see x, the coefficient a, in this case is 1, b is 3, and the coefficient of c is 2, or the constant c is 2. Now, other examples you might get in quadratic equation where you might have x squared plus 4. That's still a quadratic equation. In this case, b is equal to 0. 0 times x is 0. That's why the bx has disappeared. So that's still a quadratic equation. Another example you could get is x squared plus 3x. Again, that is still a quadratic equation where you have c equal to 0. So c is 0, that means c has disappeared. So quadratic equation can come in 3 forms. You can have it in a full version where you know where a, b, c are integer. So a, b, c are integer. Or you might have one of the coefficients is 0, or the other is 0. When the coefficient of a is 0, it's no more quadratic because x squared will disappear. And then you'll just have linear equation. So that's 3 types of quadratics you need to watch out for. They're still quadratic. Why is it quadratic? It means it will have 2 factors. Because the degree of polynomial is 2, it will have 2 factors. So 2 factors. So a factor is x plus or minus alpha. Another factor will be x. Let's just say x plus or minus beta. Alpha, beta are numbers. So these are Greek letters representing numbers. So they could be plus or minus alpha or plus or minus beta. It also will have 2 roots. 2 roots. For instance, x equals alpha and x equals beta. So that's what a quadratic equation is. A quadratic equation always have 2 factors That means two double square brackets, double brackets, and it always have two roots, alpha and beta. We can generate quadratic equation function. So this is quadratic equation function, and sometimes this function is also written as f of x. The f of x is also equal to y, where x could be a value. We don't know what that x could be, because x is the variable. So the variable are values that can change. Now, let's generate a quadratic function from the roots. So we're going to generate a quadratic function from the roots. Let's assume x equals 2 and x equals 3. So these are the two roots of a quadratic function. We can turn the x equals 2 into a factor where it can be, take the 2 to the other side, that will be x minus 2. So that's the first factor. To be quite honest, this is x minus 2 equal to 0, and that's the factor. If you take that 2 and you can turn it to a factor, move the 3 to the other side, that will become x minus 3, and that's a factor 2. So you get x minus 3 equal to 0, and then you move x, because you've moved x to the other side. When you're finding the roots is when y is equal to 0. When we look at graphs, the vertical y-axis has an equation, because this is x equals to 0, x equals to 1, x equals to 2, minus 1. The vertical y-axis crosses x equals to 0. So the equation of y-axis is x equals to 0. Likewise, y equals 1, 2, minus 1, minus 2. The x-axis, this is the x-axis, crosses the line, crosses the y-axis at y equals to 0. So the equation of the x-axis is y equal to 0. So we're going to turn the function here, the factors here, into, we're going to turn the factors here into function. That means we're going to multiply them together. So these are roots, and these are factors. I'm going to turn the factors into function. So that's root, turn into factors, factors turn into function. And now to do that, we're going to multiply the two factors. X times x is x squared. X times minus 3 is minus 3x. Minus 2 times x is minus 2x. Minus 2 times minus 3 is plus 6. And in finishing this will be x squared minus 5x plus 6. So that's y equals x squared minus 5x plus 6. To find the solution of this function, which are the roots, roots are also called solutions. These are also called solutions. To find the roots, obviously we can factorize, solve by completing a square, or solve by using the formula. But first of all, let's just sketch this curve. See how we can sketch this curve. To sketch this curve, we need to just get our x-axis done and the y-axis. x-axis and y-axis. Remember, this is the y-axis, so that's y, and the equation of y-axis is x equal to 0. This is the x-axis, and the equation of the x-axis is y equal to 0. This is minus x minus y plus y. To find so we need to put the roots in. X equals 2, so if this is 1, 2, 3, 4, so this is x equals 2 is one of the roots. As you can see, one of the roots is x equals 2, so we mark here 2, and one of the roots is x equals 3, we mark that 3. And the intercept on the y-axis, this is what C is. It's the intercept on the y-axis. That means when x is 0, if I put 0 in here, x is 0, that will disappear. You just get y equals to C. So when x is 0, y is plus 6. So if that is 2, 4, 6. So that would be your y when x is 0. One more thing. I need to find the turning point. Now the turning point, this will have a quadratic, always have one turning point. And the turning point is when is the degree of polynomial minus 1. And therefore the turning point will be 1. I've only got one turning point, because this is 2 minus 1 equals 1. How do I find the turning point? I need to use a value x equals to minus b over 2a. We will generate that formula in future. We will derive the formula in future. So that x equals minus b over 2a will give you the turning point. It will give you the line of symmetry of the quadratic. So when b in this case, our b is, our a equals 1, so there's a 1 here, 1 times x squared. A b equals minus 5, that's your b, and c equals 6. So x equals minus 5 over 2 times 1, and that gives x equals minus times minus is plus, so that will be 5 over 2, which equals 2.5. So x is 2.5. The line of symmetry is x equals 2.5. X equals 2.5 is the line of symmetry. And also at the turning point, x is equal to 2.5. We need to find y when x is 2.5. Here's 2.5 here. That's where x is. We need to find y at the turning point. So we put y equals 2.5 squared. So we're going to replace x with 2.5 minus 5 into bracket 2.5 plus 6. And that should give us 2.5 squared is 6.25, and minus 5 times 2.5 is minus 12.5. So that would be minus 12.5 plus 6, and that would be equal to, well, 12.25 minus 12.5 and that will give 0 minus 0.25. So y is minus 2.5 minus 0.25. So this is the point, the turning point. Now I need to mark that point here, the turning point here. This is right. This is 2, 1. So it's about there, very small. So if I'm drawing the graph, it's coming, turning point is coming there. That's the graph. It's a parabola. The graph of a quadratic is called parabola. So we call the graph parabola. Parabola. That's the graph of a quadratic curve. Now, the C is the intercept on the y-axis. There you go. That's the intercept on the y-axis. This is 6 here. That's the intercept on the y-axis. And these are the two roots. X equals 2, x equals 3. And the line, the turning point, and the line of symmetry is where x equals 2.5. So this is a line of symmetry. And that's the line of x equals 2.5. The coordinate at the turning point, whenever we write coordinate, we always write x, comma, y. That's what we call coordinate. So that's a coordinate at the turning point is 2.5 and 0.25 minus 0.25. There are two types of the curve. When A is positive, the A here, if it's positive, you will get a U shape. This U, it has a minimum. The turning point, so here it's the turning point here is a minimum. So that's a minimum. If A is negative, you will get a maximum, and the top of the hill here is maximum. So the parabola is maximum here when A is negative. So if you have minus x squared, for instance, and if A is positive, you get a minimum. The turning point is maximum for A is negative, and the turning point is minimum for A is positive. We can solve quadratic in many ways. One way of solving quadratic is by factorization. That's one way. Another way is by completing the square. Completing the squares. That's another way. And another way is by using formula. Another way is graphically. And finally is using my method, which I called our Shelley method. That'll be interesting to show you that, our Shelley method. Not all quadratic equations can be factorized. All quadratic equation can be solved by completing the square. You can solve all quadratic equation by completing the square or using the formula. You can solve quadratic equations graphically as well, and you can solve all quadratic equation by Awishile method. That's my method. I just coined it Awishile method. I will explain that later. 2, that's 3, and that's 4. Adding my method, there'll be 5 ways.